Alright guys, welcome back to day 2 of looking in the book. So that second section. We're going to start off by talking about parallel and perpendicular lines. So if I have the following line, it's at 2x minus 3y is equal to 0, and it goes through the point -2, I want to find a parallel line and a perpendicular line. And you see after parallel and perpendicular you have two different words. We're going to go through that, or technically two different letters. That looks like a word. It means two different words. What we're going to do first is we're going to talk about turning this equation into something I'm used to seeing. My y is equal to mx plus b, my slope-intercept form. So we want y is equal to some kind of slope times x plus my intercept value. Because the reason being is I need to see my slope. Right now, I'm not exactly sure what my slope is. And since we're going to start with parallel first, I'm just going to do it on the parallel side. It doesn't really matter where you put it. So I have 2x minus 3y is equal to 5. I want to get x by itself. So in order to do that, I need to move over to set x by itself or y by itself. And backtrack. What I want to do first is get y on one side by itself, so I need to move over the x. And we know that we keep it like a seesaw, so what I do to one side, I have to do to both sides. Well, right now my x value is with the 2, and he's positive. So to move him to the other side, I need to go ahead and do the opposite. So the opposite of addition is subtraction. So I have -3y is equal to -2x plus 5. And the reason I put the x first is if you notice my mx plus b, I just deal with my slope next to my x comes first. Next is I still don't have y all by itself, so I'm going to divide everything by -3. And I mean every single thing. So I have for my slope-intercept form of this line, y is equal to -2 divided by -3. First off, negative turns positive. Second off, 2 does not evenly divide into 3. It's going to be 0.6666667. I want to keep these in terms of fractions. So my answer is 2/3 x, not just 5. 5 divided by -3. Again, not a pretty nice little answer. So it's going to be -5/3. We want fractions because fractions help me see my slope. So going back to this beginning part. Parallel SS. That SS means same slope, which we wouldn't have determined until we moved and changed our function into slope-intercept form. So now we're going to create a parallel line, which is going to have the same slope, but goes through the point 2, -1. And what we're going to use next, we've talked about before. It is called the point-slope form. So when I do point-slope form, I'm going to take plain old basic y, so it's going to stay y. And I'm going to subtract whatever the y value I'm given. Well, in this case, I'm given a -1. So we know minus minus turns negative. So that's why I have y plus 1. He's going to be equal to the slope. And we determine the slope above, so it's 2/3. And that's going to be times by x minus whatever my x value. And in this case, the x value I'm given is 2. If you didn't notice, I got those two values from that point of 2, -1. So I'm going to go ahead and determine what this would look like as slope-intercept form. So I'm going to simplify. So I get y plus 1, because we know with order of operations I need to do the stuff in the parentheses or multiplying first. Can't simplify x minus 2. I don't know what x is, but I can multiply that 2/3 in. So I have 2/3 x minus, remember there's that invisible 1 underneath the 2. And when I multiply fractions, I do top times top. So 2 times 2, which is 4. And bottom times bottom, so 3 times 1 is 3. So my answer is 4/3. Next, I'm going to go ahead and subtract that 1. So y is equal to 2/3 x. Oops, that's not very good too. Now, we're subtracting 1, and we know that 1 is essentially 3/3, so that I work with the same denominator, because I can't just subtract by 1. I have to change it into a fraction. 4 minus 3 is 1. I'm sorry, let me try that again. I have -4, because he's got that negative sign there. Got ahead of myself. -4 minus 3 is -7. And then the denominator follows with. So a parallel line is y is equal to 2/3 x minus 7/3. Next, we're going to find a perpendicular line. And with this one, we would again put it into slope-intercept form, but we've already done so. It is already in slope-intercept form for us. We did that right here. And that OR in this case stands for the opposite. Reciprocal. So it means, in this case, my slope originally was 2/3. Opposite means opposite sign. It was originally positive. Now it's going to be negative. And I'm going to take that fraction and I'm going to flip it. So instead of 2/3, it's going to be 3/2. So my slope for a perpendicular line will be -3/2. And again, I'm going to approach it the exact same way as I did with my parallel one. So I have y plus 1, because I'm still using that same point, is going to be equal to -3/2 times x minus 2. Again, I'm going to go ahead and start by multiplying in the -3/2. Again, there's that invisible 1, so I have -3 times -2, which is a +6. 2 times 1 is 2. If you notice here, I can actually reduce 6 divided by 2. I'm just going to call it a +30. So I'm going to subtract that 1 next. So I have y is equal to -3/2 x plus 2. So a little bit of yesterday's stuff was with lines. One more example of line stuff. Next, we're going to talk about domain. And I understand that you've got that annoying block there. Just write it next to it. So the domain is all the possible values of x. I don't know what you're doing here. Okay, there you go. For some reason, it wasn't giving me my pen. So we're going to pretend that this is a -2 down here, because I noticed that it didn't get added in. This is -2, and this is the value of 4. So if I'm given the following number line, and we saw this way back in Math A when we were dealing with domain then, of what is possible and what is not possible for an answer. Well, if you recall, a filled-in circle gets really close to, but does not include. Gets really close to whatever that value is, but does not include whatever the number is. Filled-in circle does include. And domain is always dealing with inputs or whatever you're plugging in, and in 99.9% of the cases, your input or whatever the variable you're dealing with is x. So we're going to talk about this domain in terms of x. So when we deal with this guy, in the middle I'm going to be talking about x. And I want to talk about his endpoint and his other endpoint. So his left endpoint and his right endpoint. And this is really hard because I'm going backwards right now. Well, I know I'm going to deal with the numbers -2 and 4, and I know -2 is smaller, and smaller things usually go from left to right, And so that since smaller things go from left to right, on the left side I'm going to write -2. On the right side I'm going to write 4. Since we're not going to include -2, he's never going to be equal to 2. So I want my values of x to actually be greater than -2. I know if you read from left to right, it says -2 is less than x, but if you were to flip it around, it's still saying x is greater than. Remember, whatever is being eaten is what's the bigger side. So x is the bigger side, he's being eaten. However, x is also going to be smaller than or equal to 4. He can be equal because he's filled in. So to write this domain, or to put this mathematically, it says -2 is less than x is less than or equal to 4. So any number between -2 all the way to include 4. That's how you deal with writing a numeric statement that way. What about when you're dealing with something else? What if you're given an actual function? Well, we have to think about what x cannot be. Well, why couldn't x be something? Well, think about a fraction. Think of my sign that I have in my classroom. I'm going to change colors here. Can I do 1 divided by 0, or anything divided by 0? No. I can never have 0 on the bottom. It makes the function, the example, the expression undefined. So because it makes it undefined, I cannot have those values of x, which would make that 0. So I don't really care about what the top is telling me because the top's just 1. 1's always going to be 1. I'm going to focus on in this one when the denominator is going to be equal to 0. And I do not want it equal to 0. So I do not want x to be whatever would be equal to 0. And we saw this example yesterday. We know that we can go ahead and factor it out. And we have x, and we have x, and we have -2 and +2. And technically I can still set this equal, not equal to 0, just like I did yesterday. The only difference is I have the not equal part instead of the equal part. So x cannot be equal to 2, and x cannot be equal to -2. Again, all I did was solve that like I normally did. The only difference is that it has the not equal part instead of the actual equal part. So the way we're going to write this one, I can have every value, so I have to think about that. I can have every value smaller than -2. I can have anywhere to -infinity. Because we know numbers go on and on and on and on forever in the negative version and in the positive version. So because I can have any value smaller than -2, I'm going to include that. So I can have any number smaller than -2, or in this case all the way to -infinity. And when we deal with infinities, we don't actually know what that is, so we can't include it because it doesn't technically exist. It does, but it doesn't. I can't give you the numerical value of infinity, but I know it exists. So we can't include it. And we're still dealing with x's. So we have -infinity is less than x is less than my smaller value of -2. So that's saying, right there mathematically, any value that's smaller than -2. So everything very smaller. -3, -7, -1277.5. all the way until we get close to negative infinity. But that's only on the smaller part. What about on the positive side? Well, the computer does not want me to write today very well. And two. We don't want to be equal to, just like we weren't equal to with the smaller side, because if it's equal to negative 2, it would give me 0. Now we're talking about the right side. So we have everything bigger. Sorry, I have to think about that. Now we have everything bigger than 2, all the way to positive infinity. And with positive infinity, it's just infinity, just like 5 is 5. It's now we don't write the positive 5. It's just plain old infinity. But that seems like a lot of work. But wait a minute. Did we talk about everything in the middle? What about 0? Can't I let technically 0 be an answer? Because 0 would work. But 0 is not smaller than negative. 0 is not smaller than negative 2. And 0 is not bigger than 2. Oops, wrong mouse. Here's my mouse at. Mousey. Okay. Ooh, it actually works. Sometimes it doesn't work. I didn't want to go down that far. I don't know why my mouse isn't working today. So we want also between negative 2 and 2. So technically in this one we have 3. This is showing me this isn't working. So we have 3 answers for this one. And it's time for me to get a mouse. So I have everything really, really small compared to negative 2. Everything really, really big compared to positive 2. And the stuff in the middle. Okay. Next is we're going to talk about composites. Composite functions are putting things inside of others. So example of functions. So putting functions inside of other functions. And when we deal with composites, we work our way inside out. So if we look at the example on the left, f of g is the same thing as saying f of g of x. So whatever is in the middle is going to be what we put inside of the other function. So it's like saying f of, well, my g of x is cosine. So I have f of cosine of x, which is saying that every time I see an x in f of x, I'm going to write cosine. So I have 2 cosine of x minus 3. Next, I'm going to start with f because he's on the middle. He's on the inside. And my f of x is 2x minus 3. And I'm going to put that in g in place of x. So in g, I have cosine of x. So now I'm going to have the cosine of 2x minus 3. Now, if you notice between this purple and this purple, I have parentheses around my x and I don't have any here. Reason being is, if it's just x by itself, It's assumed to be just by itself. It takes a long time to put parentheses around just x by itself every single time. However, if you are plugging in more than just x, you need the parentheses around it. So you're going to take the cosine of this whole thing. Whereas in this case, you would take the cosine of whatever your x value is, then multiply it by 2, and subtract that whole thing by 3. Okay, last one. In this case, we're going to, instead of just doing x, we're going to plug in a number. So first, I'm going to start with the very inside, which is 1. Well, 1 of what? Well, we're going to plug 1 into g. That's what that's saying. Plug in 1 in g. So g of 1 is 1 squared minus 1. 1 squared is 1 minus 1, which is 0. So when I plugged in 1, I got 0. So now I'm going to replace g of 1, because I plugged it in already, with 0, which was my answer. So now I'm going to plug 0 in for f. So then I have the square root of 0, and the square root of 0 is just 0. So my final answer is 0. Okay, guys, go do your homework.